UC San Diego, and I'm going to be talking to you about the acoustic methods for sampling chiropteran or bat diversity here at Sevilleta. Alright, so first I want to talk a little bit about bats and get some myths debunked. So first of all, bats are not flying rodents as some people think they are. In fact, they're actually more closely related to you and I than they are to mice or rats. They're also not blind. So people always say blind is a bat. Bats actually have pretty good vision. Some, in fact, actually rely almost solely on their eyesight. Others, of course, do utilize echolocation because if you're flying around at night in pitch black caves, it's pretty useful to have something else to help you out. A lot of people also think that bats are just prone to flying into people's hair and getting all tangled. Also completely a myth. Because of that echolocation, they're extremely mobile and able at quickly reacting. If you see one swooping towards your head, it's probably because there's a mosquito hovering by you. They also don't all suck blood. There's actually only 3 species of vampire bats, and none of them exist in North America. They're all in Central or South America, so needing to worry about that, you don't. And they're actually really cool and they can be pretty sweet. Also, rabies. More people actually die each year from their own pets that are contaminated with rabies than they have in the entire history of being infected by bats. So what are bats? Bats are part of the Chiroptera order, which means hand wing. That is because, in fact, their wings are their fingers that are attached by membranes, which they use to fly. They're the only true flying mammal, so all those things like flying squirrels, things like that you hear, they're not actually flying, they are gliding. So bats are actually flying and are the only true flying mammal. The second largest order of mammals, comprising almost a quarter of all classified mammal species in the world, and they're extremely diverse. There's over 1,240 species, with new species being explored every single year. And they're also found on all continents except for Antarctica. So bats are pretty cool so far, right? Well, there's more. They're also incredibly ecologically important. Please enjoy this lovely cartoon. It says if you flip a picture of bats upside down, they become exceptionally sassier. So bats, why are they important? Well, first of all, they're incredible pollinators and seed dispersers. There are over 300 species of fruit that rely on bats for pollination. Everything from bananas, guavas, mango, to the agave plant. If you guys like tequila, thank the bats because they're the ones pollinating those. They're also incredible seed dispersers. So because they have the ability of flight, they're actually able to transport seeds miles and miles away than the plant could do by itself. So they're actually helping promote genetic diversity and getting those seeds all spread out. So they're incredibly helpful that way. Also, bats are insect regulators. Over 70% of bats are insectivores, so they do prey on insects. Especially all of the bats in New Mexico, almost all of them are insectivorous bats. What this means is they're providing a lot of ecosystem services. So this can reduce the use for pesticides because a single bat can eat up to 1,200 mosquito-sized insects in 1 hour. So each bat is eating between 8,000 and 9,000 insects a night. That's a lot of bugs. So that's also helping with disease control. They're eating mosquitoes that could be transmitting malaria or West Nile virus. So they're very, very helpful to us in our ecosystem. So why am I interested in looking at them here at the Sevilleta? Well, based on everything I just said, bats are incredible bioindicators. They can actually tell you the health of the ecosystem around them. So I want to know, here at the Sevilleta, what species are present? And does this vary between different habitat types? And is there a difference between species present 15 years ago where a study was conducted and today? And what could this mean? Of course, does it matter? Yes, it does. So in New Mexico, there are 28 species of bats that have been recognized, and we are not entirely certain of which bat species are present here at the Sevilleta. So in order to sample diversity, there are a couple different methods you can utilize. So the methods that we'll be focusing on are one traditional method, which is mist netting. So this allows you to get the opportunity to collect physical evidence and data and actually see in present what the potential species that are existing are in the area. And it allows an opportunity to gain data on individuals. So you can actually catch a bat, look at it, you can assess its sex, its reproductive health, its species, and actually see firsthand right in front of you what bats are around. It's obviously not without its limitations, of course. There is time, space, and presence, which I'll get a little into on this next slide. So, for those of you that don't know what a mist net is, it is essentially a very fine mesh net that is connected by 2 poles that you anchor down. And it's set up and it has little pockets. So essentially the bats have a relatively hard time seeing it, but some are pretty smart and can outsmart these nets. And they fly in and get tangled inside the pocket. When they fly into these pockets, that is when the researcher gets to come, untangle them, check them out. So what this means is, obviously, if a net is only 6 to 36 meters long, all the bats aren't just going to be flying in that same exact range. So there's going to be bats flying over, to the side, under. Some are strong enough that they break right through that fine mesh. So obviously, this can be a limiting factor when you're trying to assess diversity, and you may need other methods as well. I will note that these photographs are not bats that you'll find at the set. That is a cute little vampire bat from Costa Rica that I got all tangled in a net. Another method of sampling diversity is acoustic sampling. So acoustic sampling is essentially sonar detection. So it's utilizing the ultrasonic sounds of bats and being able to record them. You can use those calls to actually identify the species that are present. But of course, this also still has its limitations. There are certain species of bats that have calls that are too low of a frequency that it's hard for these ultrasonic detectors to pick them up. But acoustics definitely has its high advantages. So it allows us to fill in many of the gaps that mist netting leaves us with. You have a broader range of detection. Instead of only those 6 to 36 meters of capture range, you can set a mobile unit up and it can actually get something from up to 40 meters away, and it has a nice cone of detection. So anything that flies within this cone straight at it and happens to be making its echolocation sounds, the monitors can pick that up. It's also mobile, so unlike a net, once you've set it up, you can't just pull it out of the ground immediately and run over there to set it up. With these mobile units, you could walk around with it and hold it and hear bats walking around if you so pleased. It's also really helpful because unlike mist nets where you have to be there every second making sure that there's not a bat that gets trapped and is overly stressed out, with this you can do passive monitoring. So it's possible for you to set up a detector and then just leave it there and leave a memory card in it, a nice functioning battery, come back a week later and see what you have. So what I wanted to do here at the Sevilleta is, in order to assess that diversity, I wanted to sample a few sites of varying different habitats to see what's out there. So I wanted to, all bats have to utilize the resource of water because it is a life resource, and a lot of their food happens to hang around there. So I wanted to compare the diversity and see what is existing in a few of these different varying areas, such as the artificial wells, the natural springs, and also riparian edge system. So what my plan is to leave these devices out for 1 to 2 weeks in 1 to 2 week increments to be able to sample diversity. And we've chosen a couple different sites that we wanted to utilize. One of these is Nun Well, which is an artificial man-made well. Sevilleta Springs, which you guys got to hear about earlier, that is a natural spring source. And the Mesa Trail because of its proximity to the pond that we have near our houses here. So the key players, Anabat technology. What is Anabat? Anabat is a state-of-the-art technology system that allows you to record the ultrasonic calls of bats. So it's really handy, it's a nice tiny little machine, you don't have to have a whole giant thing like they used to have in the old days, so it's really nice having a small little mobile device. And then you utilize that with a software called Antelope, which will display the calls in graph formations on a computer for you to look at. So what I've been trying to do is to deploy a mobile system. This fancy thing you see right here is a combination of what is called a bat box and a bat hat. So this weird little part right here is known as a bat hat. This part includes the microphone. So on that normal device that you saw a second ago, it has a microphone pre-attached to it. You can actually unattach it, and then these special things that are made by bat biologists, they can stick the microphone in this fancy little bat hat, which has this nice little glass plate that will reflect sound of bats up into the microphone. It's essentially just a way to get the microphone out of the box and still keep it waterproof. Meanwhile, the main system resides inside the box where it can be safe from the weather. am utilizing a secondary unit. So this is an incredibly old computer system utilizing DOS, which essentially means there's no mouse, there's no normal laptop, you have to code everything that you're typing. So we connect this to the Anabat system directly, and then I mount the Anabat on a tripod. I've been sticking it out my back door for trial purposes, just to see the bats that fly over the house to get to the nearby pond. And this allows us to see real-time data visualization. So as the bat flies over, as it's making a call, you can actually see it displaying on these old-fashioned computers, and then the computer saves it to the hardware. So here's what it would look like if you were to open up the DOS monitor. This would be a bat call. I'm no expert, so I cannot tell you what species this is, but hopefully one day I will be able to do that. Every bat does have its own unique signature that will vary between these different kilohertz that you see. So that's how you can usually tell. You can tell by the shape of the bat's call and the frequency range. So this is how you would view it in analog. It's a little bit more updated, as you can see, than those old DOS computers. So this is for the other mobile unit that I have deployed on the Mesa. This way it has a little CF card reader. I just take the card reader out, plug that into the computer, and I can open up all the files in analog, and these are how they look. The only thing that I like better about the DOS computers is, whereas you look at it in analog, all you see is that graph. In the old-fashioned computers, it's pretty neat because you can actually click play and you can hear the calls as well. But it is complicated. This has a really steep learning curve, and I've struggled immensely trying to figure out how to put it together, how to read the manual. Even the manual doesn't actually answer all the questions. There's a lot of technical malfunctions, things that aren't quite working out and setting up. So hence, we don't have a lot of data yet. Have about 3 days worth of data from the one successful tripod setup out the back door. So far, all the mobile unit ones have come back with no call recordings, just a bunch of warning signals from other malfunctions happening in the device. But I am extending my stay. I'm staying an additional 1.5 weeks, which isn't enough time for everything that I want to do, but hopefully I'll be able to get a little more. Also, something I really want to do is compare data that is collected here at the Sevilleta to data that was collected 15 years ago for a BLM research survey. So the other survey was conducted between 1998 and 2002. And essentially what they did is they did a combination of mist netting and acoustic monitoring in several different areas in New Mexico to see what types of bats were present. There were only 2 sites that were actually on the Sevilleta that they looked at, and one of them was Sevilleta Springs, which I'm hoping to look at. And we're just going to see if the species are different from year to year, and if that could be because of El Nino events, the big droughts that we're having right now, habitat changes, and see what this could imply, because we want bats to be here. They are helping our ecosystem. So these are the long-term goals. We're hoping that one day, hopefully with funding and technology, we'll be able to establish a permanent system that can passively record calls and transmit it directly on the Sevilleta Wi-Fi. So this is what it looks like. They actually do have these systems deployed in other areas around the United States. Essentially, it's a solar panel with the Anabat monitor inside with a big all of its electronics things set up and a memory card. And then you can just leave it there and it will transmit through the Wi-Fi. So if this were to be set up, then me or other researchers could access these calls nightly from our home institutions wherever they are. So that's what we're hoping to do. So I have some people I want to thank. I want to thank Amaris for all of her patience and guidance during this very big struggling process. I want to thank my mentor Bill Gannon for all of his awesome technology that I'm getting to borrow and try to figure out. The National Science Foundation for this RU opportunity and the Sevilleta LTER, U.S. Fish and Wildlife for all their guidance, and then a special thanks to Michael Farrell and Chris Corbin. Michael Farrell actually was one of the writers of the manual for Anabat, and he lives in Santa Fe. I've had to call him up a few times, trying to figure stuff out over the phone. And Chris Corbin, Tilly Scientific is actually the company that created Anabat. He's Australian, but he's stationed in Missouri, so I've had to call him as well and try to guide me step by step through. Plug this wire into here, is it working yet? Send me pictures of what it looks like. So it's been a struggle, but they were extremely helpful. Right, any questions?